Welcome back to Rational Functions Part 2. Here we're going to learn how to recognize asymptotes. So asymptotes are imaginary lines that the function cannot cross. There are three types of asymptotes. There's vertical asymptotes, there's horizontal asymptotes, and there's oblique asymptotes. So in this part we're going to learn how to recognize what those are. So a vertical asymptote is what this looks like. So this is where x cannot be, and it just sort of touches this imaginary line that's vertical. So here's a vertical asymptote where on the left side it's trying to get closer and closer and closer, but can never reach. And on the right side it's trying to get closer and closer and closer to a but it can never reach. So there is a vertical asymptote here. And also there's a vertical asymptote here. Where on the left it's trying to touch it by descending, and here it's trying to touch it by ascending. But there's also vertical asymptote here. Similarly, here's a vertical asymptote at 0. And here's another vertical asymptote also at 0. So they can look a lot, but it's just wherever your graph cannot touch vertically. Horizontal asymptotes are exactly what they sound like. It's a line that they can't cross horizontally. So you can see here there's a horizontal asymptote, probably around y equals 1. So there's a horizontal asymptote here. There's also a vertical asymptote here as well. There are two horizontal asymptotes here, and there's one probably around -3, and there's one at, looks like, +1. It can't touch here, and it also can't touch here. And there's one probably around y equals 4 here. So this graph can never reach y equals 4. An oblique or slant asymptote is an asymptote that is a line. So you can see here the graph can never touch like this line right here that goes between here. It keeps trying to touch the line, but it will never actually reach it. So there's a slant asymptote. And it will have the equation of a line as well. So here's another example of that. Here's another slant asymptote. It goes somewhat like this. And another thing you need to recognize visually is a hole. A hole is a value at which the function is undefined but is not an asymptote. So it's not an asymptote, but you can never, but if you have x is 1 in this function, this line, then it is undefined. So here's a spot where it's undefined, it's a hole. But then every other value around it is fine. So in the next section we're going to find out how to find these asymptotes and holes algebraically.